Separation of the components of a mixture. The objective of this experiment is to separate a three-component mixture using various physical properties, including sublimation, extraction, and evaporation. The percent yield of the components will be determined, thus verifying the principle of conservation of matter. A mixture is a combination of two or more pure compounds. Mixtures fall under two classifications: homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture is one that has the same proportion of the compounds in each sample. That is, no matter where we look in the mixture, the proportions are always the same. Cherry Kool-Aid is an example of a homogeneous mixture. A heterogeneous mixture, on the other hand, is one that has differing proportions of the compounds in each sample. That is, everywhere we look, the mixture will have different proportions. A Jell-O mold with fruit is an example of a heterogeneous mixture. We can clearly identify the regions that are Jell-O and the regions that are fruit. In this experiment, we will separate the components of a heterogeneous mixture according to different physical properties of the components. The mixture that will be used in this experiment comprises three chemical species: ammonium chloride, NH4Cl, sodium chloride, NaCl, and silicon dioxide, SiO2. Each component has different physical properties that allow them to be separated. These include sublimation, extraction, and evaporation. Sublimation is when a solid transitions directly to the gas phase without passing through the liquid phase. The opposite phase change, called deposition, is when a gas transitions directly to a solid. The ammonium chloride in the mixture will sublimate at about 338 degrees Celsius. To accomplish this, we will heat the sample until all of the ammonium chloride sublimates. Extraction involves dissolving one component in a liquid while leaving the other component as a solid. The liquid can then be decanted from the remaining component by carefully pouring the liquid from the remaining solid. In the mixture remaining after the ammonium chloride has been sublimated, we have sodium chloride and silicon dioxide remaining. Only the sodium chloride will dissolve in water. After we dissolve the sodium chloride, we will carefully decant the solution from the solid silicon dioxide. At this point, the sodium chloride and silicon dioxide are still both in water, though they are separated. We must remove the water by evaporation. Both the sodium chloride and the silicon dioxide will be heated until the water evaporates and the samples are completely dry. At this point, we can weigh them to determine their percent composition. This procedure involves several heating and cooling steps. Additionally, there are several extra safety precautions that must be observed through the course of the experiment. Due to the safety requirements and the time limitations, it is extremely important that you completely understand the procedure for this experiment. Please be sure to watch this video and make notes along with your written procedure. The first step is to weigh a clean, empty evaporating dish. Once you have done this, you will add between 2 and 3 grams of one of the unknown mixtures. Be sure to record your unknown identity and record your masses to 3 decimal places. The ammonium chloride will be sublimated first. Please note the setup as it is slightly different than in the lab write-up. Instead of the iron ring, we will use the tripod to support the evaporating dish. The wire gauze is then placed on top of the tripod. And lastly, the evaporating dish is set on top of the wire gauze. Note that the Bunsen burner will be located under the tripod to heat the evaporating dish. It is important that the snorkel must be used during this part of the procedure due to the ammonium chloride fumes that will be generated. We can now ignite the burner and begin the sublimation process. First, you must open the gas valve completely by turning it counterclockwise until it stops. Next, make sure that the gas flow valve at the bottom of the burner is open about 2 full turns. Using the striker, ignite the burner. This may not happen on the first attempt. If necessary, open the gas flow valve a little bit more and try again. Once the burner is lit, turn the gas flow valve and rotate the barrel to generate a bright blue flame. Carefully slide the burner under the tripod. Once the fumes begin to subside, gently stir the mixture with a glass stir rod. Be very careful not to burn yourself during this process. After about 10 minutes, the ammonium chloride will be completely sublimated, and the fuming will cease. At this point, turn off the burner, but do not touch the evaporating dish. It will be extremely hot. After it is cooled for about 5 minutes, carefully remove the dish using crucible tongs and place it on a paper towel on the workbench. Once the dish is completely cooled to room temperature, reweigh the dish with the remaining mixture. At this point, only the sodium chloride and the silicon dioxide remain in the dish. The next step is to extract the sodium chloride from the silicon dioxide. To do this, first we need a second evaporating dish to hold the extracted solution. We weigh a second evaporating dish along with a watch glass. This will be used as a cover when we heat the solution. To extract the sodium chloride, we need to add several small volumes of water to the first evaporating dish to dissolve it. The silicon dioxide is insoluble in water and will be left behind. First, we pour approximately 10 milliliters of water into the cool evaporating dish. At this point, we can either gently swirl the solution or use a glass stir rod to stir it. This will facilitate the dissolving of the sodium chloride. Be careful not to splash any liquid. After swirling for 3 to 4 minutes, we must now decant the sodium chloride solution. To decant the sodium chloride solution, we will very gently pour it from the smaller dish into the larger pre-weighed dish. The goal here is to leave all of the silicon dioxide in the first dish while transferring as much of the water as we possibly can to the second. We must take our time and be very careful not to contaminate the large dish with the silicon dioxide. You will repeat this process with 2 additional 10 milliliter volumes of water. This will ensure that all the sodium chloride has been extracted from the silicon dioxide. The final step is to evaporate the water from the isolated sodium chloride and silicon dioxide. We will accomplish this at the same time. First, place the large dish with the sodium chloride solution on the tripod and begin heating it uncovered with the Bunsen burner. After several minutes, it will begin to boil. Next, set the hot plate to 350 degrees Celsius and place the small evaporating dish with the wet silicon dioxide onto it. After about 5 to 10 minutes of heating, the silicon dioxide will be dry. Carefully jiggle the dish with the crucible tongs. The silicon dioxide should move freely once it's dry. After the silicon dioxide is dry, turn off the hot plate and carefully move the dish to a paper towel with the crucible tongs. Again, do not touch the dish. Once cooled to room temperature, weigh the small dish containing the silicon dioxide. As the water evaporates from the sodium chloride, the crystals may begin to pop out of the dish. You will likely hear this popping sound when it begins to happen. We must cover the dish with the watch glass to prevent the crystals from exiting the dish. However, if we cover the dish too soon, it will prevent the water from evaporating, so we must choose the proper time. Once the solution has reduced by about 2/3, you will begin to see a ring of sodium chloride form above the solution line. At this point, use your crucible tongs to carefully place the watch glass on top of your evaporating dish. Once the water has completely evaporated, turn off the flame and allow the dish to cool. When it has cooled sufficiently to the touch, carefully remove the dish with the watch glass to a paper towel and allow it to cool to room temperature. Once it has reached room temperature, weigh the dish with the sodium chloride and the watch glass. Having recorded all of the masses, dispose of all solid waste in the appropriate container and clean your glassware. Return your glassware to its appropriate location and clean your station. It is very important that you work diligently and safely in order to complete this experiment in the allotted time. A second video will be posted in the coming days to describe the required calculations and report information.